Hi everyone, this is Team CoreDog. Welcome to our final project presentation, where we have built the Scholar Nest platform. Scholar Nest is a comprehensive platform designed to cater to users' reading and academic needs, with the primary focus on research papers. Scholar Nest seeks to streamline the process of accessing, organizing, and sharing academic content. The platform intends to enhance collaboration, simplify paper management, and provide administrative oversight. Here is an overview of the key features of the project. We provide management services for user profiles, paper organization, group collaboration, and admin oversight. We will introduce each feature in this video. This is a picture of the architecture. Let's start the demo from the front end. We access our website at the provided URL. The website is hosted on an AWS EC2 server, ensuring reliable access and a smooth user experience. We use the IDEA infrastructure as code to launch and shut down the EC2 instance.
Okay, so let's take a look on the infrastructure as code. The idea of infrastructure as code is actually very straightforward. Basically deploy or stop an instance from local to the cloud by using requirement files and tools like Terraform or Plumi or anything else, etc. Instead of like visiting the actual cloud service page then we can set everything up. Here's an example. I will show how we put up an instance on our EC2 and how we're going to shut it down by using Terraform. Okay, so as we can see on our right part, we have put up a Terraform main code, and we'll put up an instance to US East 1. Now let's go ahead and do that. First, we hit plan to see if everything can be planned well. And if we do apply, and we double check and we hit yes, then it will go ahead and create a instance for us. It will take some time to create an instance, and we will see that on the left. And it says application completed. And yeah, if we do refresh, we can see it's over here. My app instance, and we have all these like IDs, location, and configured well. So it's basically running. It may still take some time for it to initialize, but it's actually running. So if we're not using that, for example, we are not using this anymore, or just do destroy. Let's see what's going to happen. So basically we need to tell yes, we are going to delete it. So it's going to go ahead and delete this service. We can do refreshing, and there's none of it. And that's basically all for infrastructure as code and how we post and delete instances using a local tool and local files. Oh, it's still doing something on the back end. Yep, here we go. And that's it.
Now we use Google SSO for authentication. With just one click, we securely log in using Google credentials. At the same time, we use the API gateway to authorize the link to the backend servers.
I'm going to introduce our API gateways communicate with our microserver. As you can see, the logic view here, we use the Amazon Cognito to do the authorization for the Amazon API gateway. So start from the Cognito, we have two kinds of user pool. The first one is the admin user, and the second one will be the normal user. Here in the API gateway, we have two authorizer. They can do different kinds of function. That's the first one is the admin user. They can do delete, get, and put. We can see the authorization here would be the uh, admin user, and the second one is a normal user. You can only do the the get function with the authorization. So we can do the test from the Postman. First, we just get something from the admin user. Here we can input the assist token for the admin user. Okay, sorry, I input the ID token, so we can do it again. So for example, we just input a invalid token, then we can see it's uh unauthorized. So then we can just copy the access token here. Then 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 it should be like we can get something from from the microcontroller. We can see the details here, and then we can just do a put function. So we copy the link from the API gateway, this one, and just make sure the put here, and the key should be admin token, and the token here would be the same with the previous one we use here. Just add up the body. We can just like, for example, a 6159 whatever, and then we can send it. Then we can see we have upload the something with the ID and the name, and then we go back to the get. Now we get it. We can see the name change to what we just upload, and then we can go to the normal user. We already like set the link here, so we don't need to do that again. Okay, and then we change the author key to the authorization reset, sorry, and we use the access token here. We first try something unauthorized, and then we just like put into it. Okay, we can see that we get the thing we just upload, and then we can try the put, because there is no put function in the normal user pool, so we can do anything like here or chat. Okay.
Upon successful login, we are directed to the main dashboard. You can check the login user's information in the sidebar. Here's a button allows you to sign out. Click on My Dashboard on the sidebar to activate the aggregator microservice, which personalizes your space. It will assign you a group and recommend papers. The web server uses Course middleware to securely communicate with various microservices across different domains.
Okay, now let's take a look at the aggregator. Basically, an aggregator is a microservice that pulls into some info from other microservices, then integrate them together and present to the user. In our case, we have two major microservices. One is group and another is about papers. There are two working modes for the aggregators. One is synchronous and asynchronous. So synchronous will basically send requests to multiple services and wait all the information to respond. And async will basically would not wait. And in our aggregator here, we can see this API showed on the right. We have three functions, and we have the post aggregate data, we have the get user info, and we have get user paper info. And in post aggregator data, we were doing is basically allow us to put in a user ID, allocate a group, then we'll recommend 5 papers from the pool to this user ID. And for get user info, well, allows us to check if the person has been grouped. If yes, return the group and also recommend some papers to them. And the last one is basically we input a user ID and just recommend some papers to this user. And for these three parts, everything about getting a group is basically based on the synchronous services, and basically recommending papers are async. So as we can see on the left, we already ran several trials here, and now we will try that again. Basically what we'll do is try it out. And let me type in a username. We do execute, and we can see the group being pulled out. It's group number 2, and we have some papers for this person. So basically, this part is synchronous and this part is async. But we can also, but anyway, we can see everything over here also. Yeah, we can see we got some HTTPs and responding. If we do another person, yeah, basically we can have the similar thing. It's another responding, and we have some recommendations over here. Okay, that is about this part. And also over here we have a user that may not be grouped, because we don't have that much users being grouped yet. So for example, this person is also not being grouped. And here, user 1 is not being grouped yet. And yeah. Oh, the space. So basically, yeah, as we can see, it's pulling out pretty normally. And on the left, we have the responding part. For example, user 2. Yeah, we don't have user 2 being grouped yet. Okay, another thing is about doing 10, maybe even more times on asynchronous part. So here's the thing. If we have a user, here's, I think that can be counted as 1. Yeah, I would just, or maybe just a person. We can also row different papers from the pool to them. So I can do this like all the time. So something like that. You can see, yeah, we can see it works pretty normally. and we can actually pull a lot of paper from the pool asynchronously. So I think that is basically what we want to see from and what we are expecting for this aggregator. We can also do this again, maybe 55 and oh, it's not grouped yet. Okay, if we do 55 here, yeah, we can see there's some calls over here and it's being returned. So basically, these two are combined with synchronous and asynchronous systems, and this thing is purely asynchronous. So yeah, that's it about aggregation.
Let's go back to the main dashboard and check the next feature, My Papers. This section allows you to find, update, add, or delete papers. We've integrated event notifications and GraphQL.
This is a demo for the event notification feature. We implemented this feature in our paper service. So basically, when the users add a new paper, they will receive an email notification. Let's take a look at our codes. As you can see here, we have a publish to SNS function, which will send SNS message to Amazon SNS. So when a new paper is successfully added, the previous function will be called and a new SNS topic will be sent. This is our Amazon SNS, and as you can see, there is a Lambda function subscribed to it. This is our Lambda function, and it subscribes to the SNS, and it has a script to convert the SNS topic to an Amazon SES message. This is our Amazon SES service. So let's try an example here. So for example, if we want to add a new paper called test paper 12345, it says paper added successfully, and let's try to check our email. So as you can see here, we receive a new email saying new paper added, test paper 12345. And this email is sent through the Amazon SES service. This is a demo for the GraphQL part. Our team integrates the GraphQL into the paper service using the Graphene and Starlight Graphene 3 library. So we implemented a function which allows user to use the GraphQL query to fetch the paper information based on the paper ID. So here we define the data structure, the GraphQL query, and the GraphQL resolver as the GraphQL schema. So let's look at our GraphQL interface. So the GraphQL part has a separate endpoint in our microservice. So the user can use the paper ID to query the paper information. For example, here we got all these details, and let's try another example from our data. Alright, so it also returns all the information of the paper.
Moving on, let's check the next feature, Reading Group. As you can see, users can easily create, display, update, and delete groups within the platform. These functions are a testament to the CI/CD approach. It automatically updates with each iteration to enhance user collaboration and management capabilities.
Hey, I'm going to demo the CI/CD part of our project. So now I will use one of our microservices that we deploy on GCP as example. So if we go to our microservice and just start the app, you will see that the front end has displayed a message says hello from group CI/CD. And if I just do a small change of that code, I'll just do it right here. For example, if I change the CI/CD to something else like test, okay, and then I commit and push the change. In the same time, in the GitHub action part, you will see the GitHub action automatically run that deploy to GAE code to update my main PY and deploy that to the Google App Engine. The process usually will take 1 minute. In the meantime, I will go over that CISD underscore v1.yml, which is deploy.ge YML to you. So that CISD is basically I use the GitHub action to detect whatever the change is made on the Git repo, which means that like every pull and push request made to the GitHub, it will detect. And after that, they detect the change, it will automatically do the job, which is deploy the Google Cloud. And I have my secret key here, which is specific target to my App Engine. So you will just go to my App Engine and automatically deploy the changes I have made. Okay, that's basically the code. And then if we go back to the action, see if that's done. We open that and see that it's still on the deploy to App Engine process. It maybe will take 1 minute or so. Just keep waiting. Okay, so it's basically done. So what we're going to check, we're going to reopen that App Engine link, see if the change is made. Yes, the change is made. The message turned from the CORS to the test.
The external API we are using is the Zotero API, which excels in collecting, organizing, and indexing research from different fields of knowledge. After logging into Zotero, we gain the ability to import paper directly from the API. By selecting a paper, we can update its information. Additionally, we have the options to delete or create new papers. Thank you for listening.